Hi there. We're going to start in just a couple of minutes. If you can hear me, let me know. We can test the audio. Just going to start in a minute here. Give folks a chance to log in, and we will begin shortly. All right, it's 10 o'clock Mountain, and I'm going to go ahead and get started. Thank you for watching this. If you're watching live or you're seeing a recording of it, welcome to this session. I'm going to be talking today about LLMs. My name is Syed Mahmood. I have worked with data for a long time and also as a healthcare actuary, dabbled in predictive analytics, been interested in neural networks for a long time. And before this wave of generative AI and transformer architectures and so forth, so kind of been in this space, been interested in these topics. So I'm excited to talk to you today a little bit about where we are, where we find ourselves today in terms of how effective or not LLMs are at data analytics and what are the different ideas and concepts that are involved to make them work better for this kind of use case. Um, so let me go to the first slide here. And just kind of a few comments, remarks before I begin. It's a big topic. LLMs is by itself is a huge topic. We are focusing on a narrow slice of it here, but with regards to like data analytics, specifically structured data is what we're going to be mostly focused on. We will deal with some unstructured data, but mostly and think of like large SQL databases, tables, schemas, like all this stuff where we throw in our data, numbers, and then we crunch them and we produce reports, like that kind of thing. But it's a big topic, and it's intimidating. And I asked when I set up this webinar. And by the way, this is the first time I'm doing LinkedIn streaming, so please bear with me as I kind of fumbled my way through it. But I did receive some comments from people that were interested in this session. And let me kind of read some of those comments here because I think they are interesting. Kind of tells us the types of people that might be joining here today. Um, so one of the comments says, not sure what is out there and how it can be utilized right now. So that's just it. Like there's so much out there, what should we be paying attention to is a problem. So another commenter says, taking AI systems to the next level. I'm hitting a wall with single shot, fixed AI workflows and trying to get arms around design and build systems with memory, harnesses, agent skills, and loop evaluation to enable not just business modernization, but business process transformation. So this is obviously an individual who is kind of deeper into this topic. Another person says, with limited time, it's hard to know where to start in a way that makes the best use of available time. So that's clearly a pain point that time is limited and there's just a buffet of options in terms of AI. And what Where should you even begin, and what should you pay attention to? We're going to try and hopefully cover some of those topics today. And the last comment I'll read here is understanding the governance, guardrails, and risks to running agentic uh, proof of concepts (POCs) with enterprise sensitive data. So great comment there as well. Big topic, big issue for organizations. All right, so let me go back to the slide here. So just and that was just to give you a sense of the the spectrum of people interested in AI and their concerns. And then this topic itself is a spectrum. So, the AI powered analytics, you can start small. You can do intermediate stuff. I'm going to talk about how you can use it with spreadsheets. You can do advanced stuff. I'm going to talk about that. You can do custom stuff as well. And one of the points I want to make is this is not like, oh, if you're a newbie, you start with the web interface, and then if you're super into it, you go to advanced. It's not like that. Different tasks call for different levels of intensity when it comes to AI. So you can certainly, I mean, you can be the most advanced AI engineer in the world, and you would still find value in just using the straight up the web interface. So this is not to say that, oh, if you're a beginner, start here. No, it's just that different tasks require different levels of abstraction or different levels of intensity of working with these tools. And I'm going to try and cover that in the session. And I'll also make the point that you'll hear some jargon today, and I'll try to limit it and I'll try to explain it in simple terms. My goal here is to help you understand the concepts involved, expose you to the jargon because you're going to hear the jargon out there. On LinkedIn, wherever you consume your AI information, you're going to see jargon, and I don't want you to feel intimidated by it. It's not scary. Technical people do what technical people do. They create these acronyms, and it sounds like, oh my gosh, it's so complicated, but it's not. And hopefully, if I do my job, I'll try and simplify some of that for you today. So that's what we're going to cover. I'm going to hopefully leave you with a sense that different tasks require different levels of intensity, different levels of tooling. And by tooling, I just mean like a web interface or spreadsheets or CLI, which is a command line interface. I'll tell you later all about it. Um, and so leave you with a sense of like, oh, you have these different tools, and hopefully leave you with a sense of when to use these different tools as well as we go along. And finally, this is happening on LinkedIn. And like I mentioned, like this is my first time doing a LinkedIn streaming, so I'm not exactly sure how it'll work out, but one thing about questions, feel free to write your questions in the comments and I will try to get to them as we go along. But certainly I'll try to leave enough time at the end for Q&A as well. So if you're watching this, if you have some questions as we're going along, don't wait till the end. Just throw them in the comment section and I'll try and get to them during or after. Okay, so the first thing I'm going to talk about is what I call like the simple approach, and that's just the web interface. And I say Claude, but you can have ChatGPT, you can have uh, Copilot. There are all these different options out there for this sort of chat interface. I should probably call this chat interface. Um, and the idea here is that everyone's familiar with the chat interface by this time. You have these AI chat interfaces. What people are, maybe some people are less familiar with, you can actually throw in a decent amount of data in there and do some, pretty nice data analysis with the chat interface as well. So it's time to do a bit of a live demo now. So there'll be different parts of this session. I'm going to switch to um, a demo. So I'm going to switch here to this Claude interface that's familiar to you. If you use Claude or if you use ChatGPT. So basically, the idea here is in this chat interface, you can attach a file. So you can attach a file, you can CSV file or a Word document or a PDF, and you can ask a question. What I found talking to people is that it's not very clear to everyone that there's something called projects. And I think this is in Claude, but in ChatGPT, there's also an implementation of this projects. They might call it something different. Perplexity calls it workspaces. Copilot might have something similar. But projects or workspaces or whatever you want to call it, it's a super interesting um, concept. And you can set it up. You can go here, set up a new project. I have one set up here. I can go in, and the neat thing about that is you can attach files. So let's say you're doing a project and you have like 10 different files. So, without you having to attach them every time you ask a question, you can just create a project, attach all your files here, and then just ask a question. And all that context will be sort of permanent. And the next time you come here and ask a question, you don't have to attach all the files. You don't have to give your instructions. You can give your instructions over here, your general instructions of how to do the work. And then you can ask the question. So here's a question that I had asked before. And this is going to be specific to like a actuarial, I don't know how many actuaries are attending today, but um, the probably a mix of audience, and you guys might be wondering what is an IBNR or lag triangle. That's fine. The question specific niche isn't important. The important thing is I attached a CSV data set that had some data. I asked a technical question for that is interesting to me as a practitioner, and it ran an analysis, and you can expand what it did. So behind the scenes, Claude has this sort of what you call it, like a back end, if you can call, like a virtual machine that it does calculations in. So when I attach a CSV file, it loads the CSV file, it parses it, it calculates things, and I can see what it's doing by reading the script here. So if you're technically minded, you can kind of, and that's important actually. If you're using this for like real work, you can kind of see exactly what it's doing, what it's producing, and here it goes, and it produces an output. In this case, it produces an Excel file that I can download and analyze. So quick check here. Can you guys still hear and see the stream okay? If so, comment, let me know. If not, let me know as well so I can adjust. Okay, so this was a quick demonstration of projects. I wanted to mention it because not many people, even those that are using the web interfaces, are not familiar with these workspaces, these projects. Very simple, but very powerful. Um, okay, so let me go to the next phase here and show you something. And actually, let me flip back to the presentation. So the next phase is sort of this intermediate step, which is in Excel. So still, as we're talking about data, spreadsheets are the OG, still super important. Um, lots of people use them, and you can use LLMs with spreadsheets too. So let me show you how that looks like. Okay, so hopefully you can see a spreadsheet on your screen right now. So basically what I did is I took the Excel file that was produced by my web interface work. So I ran Claude, I ran Sonnet 4.6. That's the model that on the web. So when you go to uh, these web clients, you'll use different models. So if you're using ChatGPT, you'll use something like GPT 5.5. There are these specific model. It's good to familiarize yourself with it. So that's the model that's using. So these are the gigantic models that get trained by hundreds of millions of dollars. They train them, and they're called these GPT 5.5 and Anthropic on Claude. They call them things like Sonnet 4.6. So that's the model. And that produced an Excel file. I downloaded it to my laptop here. And and I open it up. And so the idea is, how do I use an LLM with my Excel? So there's this Copilot here that you can try. I tried it here. It didn't. It's okay, and maybe it works great. Maybe it's just my computer, but it didn't solve the problem for me. It kind of stalled out. But there's also these other add-ins that you can do. There's a Claude add-in. There's a ChatGPT add-in. There's probably other add-ins too. And I shouldn't be unfair to Copilot. I'm sure it works great. It just didn't work for me just in this instance. So I use Claude. And I asked a question, and hopefully you can see that question. Now, I know it's a little small, so I'll read. So I asked the question: review this spreadsheet and tell me any obvious errors. Do not edit. So that's a simple question I asked. It took like 15, 20 minutes for it to answer. So I'm not going to like run it live here because we'll be here forever. But just kind of to show you what it can do. So it kind of read the ranges. It kind of figures out what spreadsheets are in my Excel file. It reads them. It pulls the formulas. It tests them. And then it tries to find errors. So it says clear error. There's a clear error here. There's some structure. So what's a clear error? Total percentage difference is hard coded as 0. This should be 5%. And then the correct calculation is thus. And then it talks about structural issues. So no formulas exist anywhere. Significant modeling weakness. Numbers checking out. So the numbers check out generally. So the interesting thing here is you might ask that Sonnet 4.6 did the analysis, produced this Excel file, and then in Excel, I asked the same model, Sonnet 4.6, to review it, and it said, wrong, wrong, here, there's an issue, all these criticisms. So that's like me doing some work, giving it to a client, the client saying, oh, and all of this is correct, right? And then me going, actually, no, it has all these problems. So, it's interesting that that's how these models work, but that's an important thing to understand about these models and the importance of loops. Okay. So there's one word, so it's like a slightly jargony word, loop, but that just means running the model again and again. Same model. And so you run a model, it produces a result, and if you just ask it again, even in the chat interface, review your result, review what you just did and find problems or something like that. You might be surprised how often it can find problems in its own work that it just did a few seconds ago. Because these models are not like people, because a person might be like, yeah, I checked it, like I gave it to you, like, yeah, it's fine. Like I'm not gonna but that's these models work differently, and this looping concept can be super valuable, and you can find a lot of things that way. Um, so yeah, so I've been surprised how effective these add-ins in Excel can be. Copilot or Claude or ChatGPT. Um, how effective these models can be, and how useful they can be. They can edit the spreadsheets. They can create new spreadsheets, new analysis from the data that you have in your spreadsheet. So definitely check that out. This can be an important part um, of your workflow. Okay. All right. So let me go back to the presentation now. Um, let's see. So we did this the uh, the reviewing in Excel, um, and then we come to this important part in the presentation where I'm going to talk about. So everything so far we've looked at the on the web, in Excel, it's Q&A, right? So you ask a question, you get an answer. But if you think about real world work, it's not Q&A. Your client isn't sitting across from you on the table and asking you a question, you're giving an answer. It's not an interrogation. You're doing a project. A project might involve 50 different tasks. You get data, you load data into a database, you check the data, you check for outliers, you check for missing data, you check the data for reasonableness, completeness. You summarize the data to get familiar with it. You explore the data. Then you look at the questions that are interesting and important that maybe a client or your supervisor asked you to do. Then you think about questions they didn't ask you to do. Then do the analysis, you run the explorations, you look at the results, then you try to synthesize them into a report. Maybe you create a PowerPoint. You're creating maybe 5 different deliverables and a task list that's 20 long. It's a workflow. It's not Q&A. Okay. So how do we get to closer to that point where these LLMs are assisting you with workflows and not just answering your question? All right. And so there's some jargony terms here, stateful, stateless, multi-step. Some of this y- so this statefulness, it's an important concept, so I'll just explain it a little bit. I'll only pick the jargons that I think are important in this presentation for people that are interested in data analytics with LLMs to know. Statefulness is important because that's these models. So going back to what is a model? A model is these gigantic things that are trained with hundreds of millions of dollars. They're actually not very smart. So they're very smart in the sense that they'll answer your question, but they're not smart like a person. They don't Everything is gone when they stop answering a question. Their memory is gone. They don't have memory. When you're chatting on the web, there is it's called a harness. So behind the scenes, the Claude or ChatGPT, they're looping the model and they're attaching what you asked before every time you ask the model a question again. So that they're giving the model state, your context. So every time you ask a question, that context is going to that model again. Okay. So that statefulness is important when you're working with these models and when you're working with harnesses. And I'll touch upon that more as we kind of go along here. All right, so let's get into workflows, and I'll try and pick up the speed because I think I'm kind of getting bogged down here a little bit. So CLI, another jargon. I'll show you what that looks like. Nothing you get scared. It just means command line interface. Workflows with MCPforX, so another jargon. So MCPforX is an app that I built to demonstrate a super important thing. How do you encode expertise to work with agents? Okay, so I'm going to talk about that. All right, so prompts and skills can help, but they don't guarantee consistency. So, when you're prompting it, you're giving it context. There's another jargony term called skill. I'll show you what that looks like. And that just tells it more, it gives it more context. It tells it more instructions on how to do things. But that's not enough. And I'll give you a vision of what might be more closer to being enough when you're dealing with these 20-step workflows. Okay. So I'll talk about that a little bit more. I'm not going to read the slides here. So hopefully you can read them a little bit, but don't worry if you can't. I'll kind of talk through them. Actually, before I go and show you what MCP4X looks like, let me show you an example of a skill, right? So, and I'm going to show you an example of a skill using another app that I built called VerbaGPT, and it has the ability to add skills of different types. So let me kind of show you what a skill looks like. So, for example, um, analyzing climate data. Okay, so I have a skill here for analyzing climate data. So here you can add comments like, oh, climatological seasons are separated by MAM, JJJ, like these different um, months. When you're fitting the data, um, use a particular test to verify normality of data. An agent, if you leave it to the agent might do something else, and it will. Okay, so what a skill does is, and you're just typing it in. Okay, you just type it in and say, um, always run a normality test. Okay, and you just update the skill, and the next time you ask the agent to do a climate analysis, it will do that. Okay, it'll run that test. So that's the idea of a skill. Once again, as you can see, nothing to be scared of or intimidated. It's pretty simple. You just type stuff in, stuff that you want the agent to always remember. And the important thing about skill is that the agent can go back to it repeatedly as it goes, tries to answer your question. So it's not like you give a prompt at the start and that's it, and then the agent goes off and gives you an answer. A skill is something where you give the prompt, then the agent looks at the skill, and then maybe the agent gets stuck, then it goes back to the skill. Okay. But then you have something more powerful, more souped up, and that is what I call a tree, an expertise. Like it's an expertise is not like a skill. It's a combination of many different skills. Like if I have expertise with data analysis, I know how to analyze data. I know how to load data into a database. Maybe have SQL skills or Snowflake skills or Azure skills, or I maybe have actuarial skills that I know how to analyze data for certain actuarial tasks. All of that combined together is expertise. All right. And how do you encode the expertise so that the agent can consume? This is an incredibly profoundly deep topic, and I can spend 3 hours on this, but I just want to give you a taste. So we started with prompt. You ask a question. Well, it's just a question. You ask a question. That's just a prompt, right? And then skill, that the agent that you're asking a question of can go back to and see what you wrote and try to make sense of it, and it won't do the job perfectly. And then you have this concept of expertise, which is this, not just that it's a combination of skills, but it's something that actually guardrails the agent's execution. So let me show you an example of that. Um, okay, so hopefully you can see this, my MCP4X screen here. Um, and let me pick up this healthcare prior authorization. Actually, let me look up the IBNR expertise. So this is simpler. So let me make it a little bigger so you can kind of see, hopefully. Uh, okay. Um, so here is an example of an expertise. This is a sequence. So what this is saying is do this. So load claims data, validate each row, so forth. Then once you do that, then proceed. Then build cumulative pay loss triangle, calculate age to development factors in a particular way. So you can think of this as one skill, right? But this is me chaining a bunch of skills together into this one expertise that the agent can execute, right? So select tail factor. And once again, this is an actuarial example, but you can imagine this in any domain. So whatever you do analysis with, you can kind of set up a sequence, and then the output that it produces, and where to produce the output, where to output it, what format, and so forth. Okay. Um, and so let me show you what that looks like when you run an agent on this expertise. And by the way, this MCP4X, the idea here is that you can encode your expertise as a professional, and then you can go and connect it to any agent. So whether you're using Claude, Cursor, Codex, so these are all these CLI agents, and I'm just going to show you what that looks like in just a second here. Please come on. But I want to give you the impression that this is not something that works just with Anthropic or OpenAI, and I actually have a lot to say about that, and maybe I'll get to that in the Q&A. But these expertises are yours as professionals and as enterprises, and you should be able to use them with anything that you choose, any kind of model. And I'll show you here an example um, that I ran before. It took 3 minutes to run, as you can see here at the bottom, and hopefully you can see a CLI. If so, let me know that you can see a CLI on your screen. I'm kind of flipping through different modes on my stream here. But so here is what the CLI looks like. It looks like a DOS prompt. I'm old enough that when I learned computers, I learned how to write in DOS. So, how to open up a DOS prompt and write a command. But that's how a lot of these models work. And, you know, interestingly, these models are super powerful when you're running them in the CLI mode because they can run for longer and they can do a lot more things because the CLI, this command line, what you're looking at, is running on my laptop. So it has access to my local file system. So it can create files, it can analyze them. It also has access to a Python. So if you don't know Python, it's what enables these to do computations. So you can do computations that way. And so here you're looking at a CLI specifically called Open Code. So not a Claude Code, but it's the same kind of similar thing. I think Open Code is actually better and free and open source. So I also have a lot to say about things that are free and open source. I think they are awesome. Um, and I think they're going to be super important when the real costs of inference come home to roost for organizations. Okay. So here I just asked it because I've already connected it to MCP4X. I asked it, run IBNR reserve analysis expertise. That's all I asked. And it's checking the expertise. It's checking at the first step what it wants to do. It's analyzing it. Then it's going back to the step and it's validating it, right? So that's the important thing. It's guardrailing, it's gating the execution of the CLI agent. If you just give it a prompt, if you just give it skills, it's just going to do whatever it wants. It's not going to give you the right answer every time. I'll just show you an example of what that looks like. But if you use this tree structure or this gating structure, which actually gates the expertise and runs it exactly like how you want to run it, as a professional, then it becomes a transferable process and a repeatable workflow. And you can have reliability in that. So these are super important, deep concepts. I don't have the time to go into these in depth, but just I want to show you what it looks like. And by the way, MCP4X, whatever I'm showing you is available. You can play with it online. MCPforX.com, you can play. Um, there's a free tier. You can make expertises and test them out. I think you'll find it super interesting. So here it runs the entire expertise and produces the answer that I want. So you can see that it's a long thing, right? It's doing some heavy duty computations. It's doing a bunch of stuff. It's producing an estimate of IBNR reserve. Okay, now let me go back and show you why it's important. Um, Let me go back to my presentation here. So it's important because when you're using a prompt or a skill, the agent ends up making a lot of methodological decisions. And the consequences of that are huge. I mean, we might think these things are intelligent, and you can just because there's a lot of hype out there, and people might say, "Oh, you can just tell it to do something and it'll do it." That might work when you're working with low stakes things that aren't very complex. But if you are an expert in a domain, I'm sure you'll agree with me that if you run something that you are yourself are a top level expert in, you will immediately see the problems. You will immediately see that. And actually, it doesn't, I don't even have to convince you. It's, I can show you proof. So let me show you. Okay. So you can, for proof, you can go to my Substack. So it's mozayan.substack.com. I'll try and leave that link in the comments. Actually, I'll try to leave links to all of these things in the comments. And by the way, comment if you want anything from out of this. I'll make sure to get it to you. But the interesting thing is that you don't even have to believe me. Just run your prompt again. So here's an example where running the same prompt on the same agent and the same exact model, the same exact data, produced IBNR estimates, exact same information. So all the information is exactly the same. The context is the same. It produced IBNR estimates from 46 million to 97 million. That's not a repeatable workflow. Versus if you use the exact same context, so nothing, not cheating here, use the exact same context, but instead of putting it in a skill, which is a flat document, you put it in a sequence or a tree like MCP4X. Look at it's still not exact. There's still a few dollars different between the different runs, but it's almost identical because it gates the execution. It guardrails the execution. It stays true to your intent as an expert. It can disambiguate between conflicting information and information that's very similar because these models are next token predictors. If you have context, you have one instruction on line 11 and another on line 34 that's similar, it'll just choose whichever one it wants to run it on the next token prediction path. But if you have something in a gated workflow like an MCP4X tree expertise, it guardrails the execution. So you get a result that you can actually repeat. Super important. I can't tell, like, if you're going to do real work with LLMs, it's fine to do a demo that looks great. And then you want to run the demo again. Oh, no, 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 let's not do that because it might give you an answer that's twice as high. That's $50 million off. So, everything you're seeing online today is like, oh, these LLMs are so good. They are not. I ran the same model on Opus 4.8, the best model available you can do. It gives you wildly different answers. Repeatedly you run. And if you take the exact same context and you structure that context differently, you make it a structural workflow like MCP4X, like a tree, that's when you start getting reliability. Okay, anyway, enough on that. And actually, let me show you a, a live demo because I want to show you at least one live demo. Um, how it works, like how a CLI looks like, um, so that you can kind of have a sense of that. Okay, so let me do a new session here. So I'm just going to show you my workflow here. Okay, so hopefully you can see a CLI. If you can see a CLI, let me know. And once again, it's this DOS looking thing, command line interface. That's what the CLI is. Just let me know in the comments or thumbs up. Okay, all right. So here I'm going to talk about run session initialization expertise. So this is what I do at the start of every session because it sets up my environment. It tells it it's running MCP4X as well, but it tells it where my Python is. It tells it to read what's uh, in the folder, what files are in the folder, familiarize yourself with it, and then ask the question, right? So I'm going to ask the question here. So now it's initialized. So this is also very valuable because it kind of automatically sets me up to ask my question. And I'm going to ask my question here. So you're a prior authorization. So prior authorizations are a huge thing in healthcare. So run this expertise. Um, and while it's running it, so you can see it's checking with the tree. And let me show you what the tree looks like, okay? I should have shown you that before I went there. Let me show you what that tree looks like for prior auth. Um, so this is what that tree looks like. So this is not a sequence. So before for IBNR, I showed you one step going to the next step. This thing looks like a tree where it branches based on the results of the previous step. So imagine you're an expert, right? And you're trying to do something where like, okay, if you get results like this, if the data is bad, what do you do then? If the data has something bad that looks like this, or some missing data that looks like this, or if you get results and they look unreasonable, what do you do? These are all elements of an expertise. But if you just throw that in a prompt or a skill, the agent may do it, the agent may ignore it. But if you put it in a gated workflow like this, I mean, it looks a little crazy, but then it will follow it. It'll stay true to your implementation of it. And it takes work to set it up this way, but it makes it more reliable that way. Okay, so let me go back to the prior auth, as it's already done. So it produced these outputs. So basically, what this tree is doing is looking at a whole bunch of documentation. And in this folder, there's like 15 different documents. So this is like a real world unstructured data example where you have this different documents, policy manuals, what to do in different situations, PDFs, etc. And it's trying to run that workflow. The exact same context is in the tree format. Okay, so the tree format produces this. So it produced the answer, took a minute. Um, Let me go back and show you what it looks like with just the skill approach. So that once again, this is on mosayan.substack.com. So if you run it with a flat approach, just give it the document. So imagine attaching PDF files and asking a question. It answers 6 out of 16 cases correctly. So prior authorization. So you're trying to approve or deny requests to authorize treatment. And so it answered 6 out of 16 correctly. If you do a decision tree approach, all of them are correct because it's gated, it's guardrailed, it's following the same exact instruction. So whatever is in the flat prompt, you structure it differently, it transforms the results. Okay. So so I know this is getting a little bit heavy and technical. So let me try and recap it. So we started with a web interface, we talked about prompts, we talked about skills, all important. But when you start getting into real heavy duty workloads, you really start to need thinking more complex, and you can take the exact same prompt and you can use something like MCP4X or make up your own way to encode your expertise as a gated workflow where when the agent does something and produces a result, it goes back to the tree and sees what the next branch it needs to go down on that expertise, right? So depending on the results it has, so if the data was all good, great, it'll go to the next appropriate step. If the data wasn't quite right, it'll go to the next appropriate step, which will look different. If the results look like, oh, it's on a prior authorization for a particular procedure, it'll go down to just that part of the context that deals with that procedure versus throwing 50 different documents and a million tokens at the agent and praying that it figures it out. Right. So these are super important concepts. So hopefully I'm giving you a flavor of things to think about as you're working through your uh, through your use cases. Okay. So the last part of my presentation is about purpose-built solutions. So I'm going to try and wrap up pretty quick here to see if there are questions. Uh, and once again, you can write your questions in the in comments, uh, and I will try to get to those comments as I get through them. Okay, so the last section is purpose-built solutions. So here we're talking about not workflows. So for workflows, when you're trying to do 50 different things in one go, that's more complex. Imagine that you want ad hoc analysis. So when you're using LLMs with data, sometimes you have a project you need to complete, which, like I said, is a workflow, is 50 different things you're trying to do. Sometimes you're just trying to do ad hoc analysis. You just want a question, you want to get an answer. And that's in some ways a simpler concept, but in some ways it's not as simple. So the things that you have to think about are having too many tables. Like you have databases, you have tables, you might have many different tables. Like how can an agent understand what you mean when you ask a question about something? Um, to disambiguate, the gap between a particular concept. You have different columns that are named similar, and so the agent will give you the wrong answer, or not the answer that you expect. The knowledge might be stale. That just means you need to constantly maintain this context. Um, and then a few other concepts as well that are important. And the overall comment I'll make here is that once again, you can't just point an agent to a database and expect it to work. Context has to be provided, and a human has to be in charge of that. Like a really important point. So if you read my post on LinkedIn, like I really stress the primacy of human labor. And I stress that for a couple of things. One, because I'm human centric. Like, I guess I got, I feel like I have to be. Like, I'm human. But like, that's actually the right thing to do because these agents, once again, these are next token predictors. They're just not good enough to disambiguate on their own, but they can be tremendously helpful. They can put together, give you a great start, but then a human has to figure out what that context looks like. And this is just a slide here. Anthropic did their research, and this said that with skills and context, accuracy goes from 20% on data queries to over 90%. And I found the same thing in my work with VerbaGPT as well. So there are different ingredients. So there's rich context, skills we talked about, guidelines. Think of that as like a simpler version of skills. So skills are longer. So I showed you an example of a weather skill. Do this, do this, do this. A guideline can simply be don't do this, for example, on this type of question. So it's just like a one-liner, and they can be super useful as well. And memory. So we talked about statefulness and things like that. So data nodes. So I can talk about this and then I'll kind of show it to you very quickly what data nodes looks like. But here the idea is that you have context at different levels of your data. So there's a layer of context at the database level. What is this database about? There's a layer of context at the table level. What is this table about? Column. What does that column mean? A specific value in a column. For some important values, you can have some context there as well. Sample questions can be important too. So let me show you what this looks like using an example from VerbaGPT. So here I'm going to go to the sample database. And by the way, VerbaGPT is free. You can kind of do exactly what I'm doing on your own as well. So data notes, I'm going to go here and show you just an example of what this context looks like. So not very complicated. So this is a database level note. Just says what that database looks like. This is a column level. Not every column needs to, if it's self descriptive, you don't have to put a description down, but otherwise you can put it down and then you can curate this over time. So the better you make these descriptions, the better answers you will get from your agent. And you can collaborate on this, with your team. So you can kind of make it better together. Um, and so this is one layer. So this is what this data nodes concept looks like. And this can really make your data queries better. And we talked about skills and guidelines and expertise. You add all of them up, and your queries can get really, really good and reliable. One thing we didn't really talk about is improvement through feedback. So this is also super important. So one thing is to like consciously, like proactively going in there and adding skills and guidelines and setting up expertises for workflow. Okay, let's not talk about expertise anymore. We're talking about ad hoc queries. So we like proactively setting up skills. But the other thing is to collect feedback from users. Let's say you're in an organization of 1,000 people and you provide an agent to them. Their interactions with that agent can help self-improve the agent. Whether they are thinking that the query was good or bad, that can be super. So let me show you an example of that in action. Uh, so here I'll ask a question. Uh, so from iris data, show me a pie chart of flower species distribution. So the agent is connecting to the database. It did a lot of things quickly. So this is super fast because I'm using an open source model. Once again, a huge fan of open source. And it's doing a bunch of things. It went in there and it found a thumbs up match. Okay. And so it was able to extract code from that. So it doesn't have to write that code again, put that in the prompt. Like it enhances my prompts. My prompt was a simple from this data, put together a pie chart. But then it appended that code to the prompt so that the agent didn't have to do that much work to kind of provide the answer. And then Another important concept when you're working with data is to have provenance of sources. You can kind of look at sources and say, oh, it used the iris table, it used the guideline, used yellow instead of orange for the pie chart, it used a past reference. So somebody ran a query before that was very similar and thumbs up that query, so this agent learned from that, and the next time it didn't run into any glitches or errors. It gave me the answer in 7 seconds. All right. Um, this is that this concept in action of self-improvement through feedback. Okay, so the deeper you go, the more production ready it gets. So this is another kind of concept of the continuum, where the more you work, the more of these pieces you put together, um, the better your agents are going to be. And, the more production ready, the more real work you will be able to accomplish with these examples. So let me open it up to questions at this point. And while you're thinking of questions and asking them, let me actually show you some examples as well. Okay, so real world examples of other things in action. Let me actually switch to a messier database, which is this data set called MEPS. So this is like a heavy duty query. It's like create deciles for normalized total expenditure, that particular table that shows weighted normalized expenditure for deciles, the weighted average. Actually, I'll just run it and then read it. Um, uh, and also the average normalized concurrent and prospective risk scores. Give me bar and line chart and some other visual that relays this info well. This is not a non-trivial query on a data set that has over 200 like different tables. I'll kind of show you what those tables look like. Actually, let me show you that right now. So, I have these different tables. So 35 columns, 153 columns, 230 columns, 69 columns, and these are hundreds of thousands of rows in each of these tables. So this is a heavy duty database, very messy, de-identified individual level claim data. So, uh, this is something healthcare actuaries do, but you don't have to worry about. I'm just kind of showing you this example, but this can be any data, but it did it. It produced an answer that's very good, and of course, it used guidelines and past references to answer that, and also did it pretty fast. And that's the other thing about feedback and putting skills, that it really reduces the latency, so you can get answers pretty quickly uh, to the questions that you have. Okay, so let me go back to a different data set, maybe a more fun one. Maybe I'll ask some question about tennis that doesn't have a previous question or guideline or skill. So maybe it will fail. Let's see. Compare and contrast Rafa Nadal's performance on Wimbledon versus Roland Garros. So kind of an ill-formed question. And once again, this data set is actually tens of thousands of rows and very messy because it has different tables at the back that are very similar. So the agent may not know what to look at or look for, but let's see. See, it ran into an error I saw very quickly. So let's look at that. So this is how an agent recovers. So another important it did answer. So it did recover and answer the question. But let's look at, so it was trying, it's going through, answering the question, ran into an error. So here's what the error looks like, and then recovered and then answered the question. So that's the beauty about these agents. Like, you don't have to be perfect. You don't have to format your prompt perfectly. And if I thumbs up this question and ask it again, then it won't run into an error. It'll do it, but it doesn't matter. Like, errors are not nothing to be afraid of. The agents, if it's a good enough harness, it will recover from it. And once again, the model is something that these labs produce. A harness is something that loops the model. That's one way to think about it. So Claude Code is a harness. So here in VerbaGPT, I built my own custom harness that help, that is specifically built for working with databases, and does it fast, works with free models and so forth. And by the way, yeah, these databases are all available on VerbaGPT. You can kind of play with them yourself. All right, so let me see if there's any questions at this point. So there's one question: how to decide when to use which tools? Uh, Elaborate when to use these VerbaGPT or MCP4X. So I think these tools are when to use which tools. So if you're doing ad hoc queries, um, something like a VerbaGPT would be very good for it. If your data set is super small, if it's a CSV data set, you can just plop it into ChatGPT or a Claude and ask a question, assuming that your organization permits you to do that. I mean, all this check permissions and organizational licenses and so forth. But you can do it that way. Um, if it's heavy duty data sets, you have to connect databases, something like VerbaGPT, Databricks. Um, my understanding is they have something like this. Um, so so for ad hoc queries, something like that. When you have workflows, you have you're professional, professional services, you're looking at a workflow, you have a project that has like 20 moving pieces. You want to see how much of that you can automate or get help from an agent from, then you're looking at encoding your expertise. So that's when you're looking at something like an MCP4X. You're looking at encoding your decision making process that you can use with any agent that you choose. Okay. So that's when you're looking at an MCP4X, some kind of repeatable workflow. And if you just have like a one off ad hoc query, you're looking at something like a VerbaGPT. Okay. If you're just looking to explore things, you want to work locally, you have some CSV files in a folder, then you can invoke something like an open code or a Claude code, okay, that is like a CLI, and you can ask it questions. It's a little bit more complex. And once again, you have to check your organizational, if you work at a company, what their policies are, what tools you can use and all of that. Uh, but um, but that's when you start looking at some of these local things to use as well. Cursor is another option. All right, so let's see. Let me check if we have uh, questions here. Open source models as good as I think that'll be the last question before I kind of do it. But feel free to add any questions even after this live stream is done. I will try and answer those. I will monitor and answer those questions. If you're watching this later and you want to ask a question, feel free to ask it under this live stream. I think that's how LinkedIn works. I'm not sure, but we'll find out. So if you can comment it, then I will answer it. So last point on open source versus closed. This is a super important thing. So if you're looking at this and it's like, why is Sayed talking about open code, talking about open source models? I'm sure some of you are already starting to get more familiar. I've been talking about this for 2 years, but this has been more in the news recently because the subsidization tide is finally going out, and the real cost of inference the organizations are starting to feel. That bill for inference is thumping down on the desks of CFOs countrywide right now, and that is only going to get much bigger as the loops get much more bigger as well. More tokens get burned on every query. um, it's a we're all organizations are all competing. These are competitive markets. If you're a professional services firm or an engineering firm or whatever you are, you have competitors. And if you think AI is great and you use an enormous amount of it, let's assume, your costs, and if you're using only the frontier models, like, we only do Anthropic, or we only do ChatGPT because that's what our organization will approve. Your cost might be 30 times that of your competitor. You will not be able to compete in that world. It's game over for you. So this is super important to understand. These models and tools, Claude Code is actually the worst harness you can use. And don't believe me, go and look at Terminal Bench. The open source harnesses like Open Code, and there are others, are so much better. Okay. And then you go to open source models like the one I was using, the ZAI GLM model, or the um, there are these other models these days. There's like I think there's Kimi has good models. DeepSeek has very good models too. You can get 30 times less inference. And by the way, some people think that, oh, if I'm using these models, the data is going to China. No, it's not. These are open weight models, which means US firms load these models and provide inference on US hosted servers. So there's a lot to learn in this space. So if you think like, oh, using open source models is somehow less secure, or your data is going somewhere else, or it's not as good as the frontier, wrong, false. You need to learn, right? And the sooner you learn, the better off you and your organization will be. Now, let me caveat it by saying, okay, these open source models are not going to be as good as Fable or Mythos. Okay. Some of these absolutely bleeding edge models are going to be better, but you don't need the absolute bleeding edge model for your ad hoc database queries. Okay. The models I was showing you, I was running this fast inference at 1,000 tokens a second. These cheaper models, super cheap models, are amazing as data inference. Don't believe me? Go check out VerbaGPT, run queries, go nuts. You will see. So I know I covered a lot of ground here. Some of it was pretty fast. Feel free to write in comments. Uh, any questions you have that I didn't get to, feel free to write to me. I'll be happy to answer those questions. Thank you for watching this stream. I know we covered a lot of ground, but hopefully some of it is a little bit clear. I know some of it is muddier than before, but I think that's good. That's all part of learning. When you're learning something, some things you're gonna have more questions than answers at the end of it. But ask those questions, and I'll try to get to them. Thank you for watching.